Let's do another example together. Problems 31 and 32 were assigned from section 1.2 in the textbook, and we hadn't gone over anything like this in class yet. So let's take a look at number 31 together. We're given information, and we're asked to sketch a graph of a function that meets this criteria. Now, for starters, I just want to make clear that there's many different answers that can be correct and meet this criteria. So answers might vary, but here are some of the things we'd look for. For starters, let's start with this first statement. F of 0 is undefined. That could mean a bunch of different things. That could mean there's a hole in the graph at x equals 0. It could mean there's a vertical asymptote in the graph at x equals 0. Or it could just simply mean that 0 is not in the domain of the function, and that's all there is to it. So we need more information. In the next part, it says that the limit as x approaches 0 of f of x equals 4. Now let's piece these two together. If the limit exists, that means our function's approaching the same value from the left and the right. And if at x equals 0, our function's undefined, that must mean there's a hole. So there's going to be a hole in the graph when x is 0 and y is 4. Okay? All right, let's keep going. The next thing we're going to look at is that this statement, f of 2 equals 6. That just means that when x is 2, the y value is 6. So we'll plot a point. Not using graph paper, so we'll estimate the best we can. And now finally, the last statement. It says the limit as x approaches 2 of f of x is 3. So that means when x is approaching 2 from both sides, the y value is approaching 3. So this is going to be one of those weird types of graphs that we saw in class, where our function approaches one value but is defined at another. So now the way we fill in this graph is where the answers could be very different. Let's start by looking at this part here when x equals 0. We know that we have to approach y equals 4. So I don't know, I'm just going to do something like this. We'll approach y equals 4 from here and from there. Next, since the limit when x approaches 2 is 3, we're going to look at this point. When x approaches 2 from both sides, the y values must approach 3. So I'll go like this. Oops. Hold on a second. So I'll go like this, and then continue on. I guess that's all the information we have. So I'll throw an arrow here, an arrow there, and this would be one answer that meets the criteria. That's not the only answer. Somebody might have looked at it differently. They might have viewed it like this. We approach 4, we come down, we approach 3. Who knows? There's infinitely many ways to interpret this, but there must be a hole at 0, 4. There must be a hole at 2, 3, and there must be a dot at 2, 6. Anyways, I hope this makes a little sense. Go ahead and try number 32 on your own and see if you can piece together a graph that meets the criteria. Hey, don't be surprised if you put something down, check over the criteria, and realize there's a mistake. You need to erase it and adjust the graph. These things don't always come out right the first time. Well, thanks for watching the video. I hope it was helpful.